Welcome everyone to another edition of Drunk Agile. With us as always, the star of the show who just took her spot in the limelight there, Nisha. Hi, Nisha. Also with us, we have
Prateek Singh.
And my name is Daniel Vacanti. As always, Prateek, what are you drinking tonight? The thing you're going to kill, right?
I don't know if I can kill this, but although I did pour a heavy pour here, so it's my Blanton's. I have another bottle on its way, so it's time for this one to kick the bottle. But yeah, so this one, it's a Blanton's. Can't say much more about it. 93 proof, beautiful little whiskey. Another one on its way.
Yep, and I'm still working through my Aberfeldy. I'm hoping to replenish, augment, whatever word you want to use, my stock tomorrow. Tomorrow, everything going well tomorrow. If not tomorrow, then the next weekend for sure. So, but the Aberfeldy will definitely do for now. So, so cheers, everybody. And I'll introduce the episode tonight so you can start doing the talking, if that's okay. Common question we get in all the coaching engagements we do, all the trainings we do around metrics and predictability, and that is, how much data do you need in order to get started with doing any basic kind of probabilistic forecasting? Several answers to this question. So I don't know, Prateek, do you want to start us off?
Yeah, the simplest place to start is you probably need less data than you think. And most likely you already have access to all that data that you need. So just to preface everything else, you probably need less data than you think. So you can probably start doing this today.
Yeah, we get people come in with the assumption, and it's not necessarily a bad assumption, but it is an assumption that that number one, you just need a ton of data in order for probabilistic forecasting to work. That you have to have a ton of data, and they might even go so far as to say, "Oh, but we have no data." Right? Usually, both of those assumptions are wrong. Number one, you don't need as much data as you think you do, as we're going to get into here in just a second. And number two, generally speaking, the problem isn't that you don't have enough data. The problem is usually you have too much. And you need to figure out what stuff is relevant. So let's talk about both of those aspects maybe for the rest of the time. Let's talk about the first one. How much data do we need? If we don't need as much as we think that we do, how much data do we need?
Yeah, we just to prove it to everyone, we did the math on this.
We're gonna have to edit that out because I don't know that we should show that.
We literally did the math on this, and we did the math before we started to drink whiskey, which I don't think makes it better, but still. What we were trying to figure out as we were doing the math, because both of us had heard in the past of how uniform distributions and random sampling with those work, is how many data points do you need in order to be comfortable or be confident with your forecast. And as we were running through the math, we got to, if you have about 10 data points, you can be around 80% confident that the next data point that you get will fall within the upper and lower bound of those 10 data points, which means as soon as you have 10 data points, you can start having these probabilistic conversations with an 80% confidence.
Yep, we'll bring in a whole bunch of caveats to that a little bit later, but there's a reason. I don't know, for those of you who use Actionable Agile, number one, if you use Actionable Agile, thank you for the support of the tool. But if you do use Actionable Agile, you probably notice that if you ever load less than 10 data points, the charts won't work. And there's a reason for that, is because we want to make sure that we have enough data to be able to calculate all the things that we think that we need to calculate, on those charts. So you'll see an error on a lot of those charts if you try to load less than 10 points. The data will still load, you just won't be able to use the charts for the most part. And it gets it gets, incrementally better from there. I mean, and what we found as we did the math, once you get up around 20, so 10-ish is the probably pretty close to that lower bound that you need. Honestly, once you get up to around 20, you're sitting pretty good, especially if you have a stable system, which again we'll talk about here in just a second. But 10's not bad, 20's pretty good. More than that, potentially better. So I don't know, maybe we should start, because I keep hedging my bets here, maybe we should start talking about some of those caveats about more data be better than less data. I mean, in general, I think it's reasonable that more data is better than less data, but let's talk about the caveats to that. Why might more data not be better than less data? Can you start us off with that?
I think you already alluded to one thing about it, which is if you're running an unstable system, that's probably the base of it. The time period that you pull the data from, when you're running an unstable system, you would probably see something like things are taking longer and longer to get done as time is going on. In that case, you might have 500 data points, but because the system is unstable and things are taking longer and longer to get done, those 500 data points are not going to be very good at predicting what's going to happen next.
Right.
So if you're running an unstable system, it probably doesn't even matter how much data you have.
And that's the fundamental point. I think that's a fundamental point that we try to make in our trainings, is that asking how much data do you need is usually, especially when you're starting out with this, is usually the wrong question. The much better question is, how is the process that is generating this data, how is that process performing? Because if it's performing unpredictably, as you just said, I don't care how much data you got. You use whatever estimating forecasting technique that you want to, they will all be equally bad. And if you have a bad process generating bad data, more data ain't going to save you, right? And in fact,
did you just say that if your process behaves unpredictably, you cannot predict it?
I know. Oh no, it's a Yogi Berra-ism. I stole your thunder. Uh-oh. All right, we'll have to save that for the Twitter on this one. Spot the Yogi Berra-ism for Dan. I don't even know what I was saying now. So help me out. What was I?
Just that you were essentially saying that if your process is inherently unpredictable, you cannot predict it regardless of how you try to predict it.
Go figure.
Yeah.
So yeah, use like I always say, use whatever technique you want. Mm-hmm. I don't care. Insert your technique here. It will just be bad and it will not work. Okay. So that's number one. If your process is not good, then the bad data you have coming off of that will, the past that you have data for will not be a good predictor of the future. Okay. So that's number one. Okay. Number two. I have a number two. I have a number two. If you'd like me to go next.
Oh.
So the second point.
I'm not editing this.
I know, that's fine. The second point that we would like, that I'd like to make is with the whole more data is better than less data, and this is kind of a corollary to what we just talked about, is generally speaking, more recent data is better than less recent data. So you don't necessarily want to load 5 years worth of data just for the sake of getting more data. Generally speaking, that's just silly. That's a stupid thing to do. As I just said, you want to load just enough data where the data you're loading from the past roughly exhibits the same characteristics that you expect how your process to behave in the future. You want to say something about that?
Yeah, that's. I mean, there are multiple reasons why more data in that case can make things worse than better. If you've made a major process change, if you've gone from doing process X to process Y, or if you were not really paying attention to things like aging and now you've started paying attention to them, you don't want to necessarily include the data from that earlier process to predict how the new process behaves.
Yep.
If you've had major changes on the team, that's another one.
Yeah. You ran into that, right? We added 10 people to the team, or in your case, we took 10 people off the team, right?
What does it
whatever
look
the
like?
case may be. Yeah, at that point, generally speaking, and again, we have to caveat that with generally speaking, more recent data is better than less recent data. But Prateek, where can more recent data still get us into trouble?
Yeah,
What do we have to watch for there?
it's again the same reasons why earlier data might have been bad kind of apply to more recent data as well. If you're, I used to work with a team that was very seasonal in the way things came to them. For them, December and January were heavy. There was a lot of taxation related stuff that they dealt with. I would not use January's data to predict February, because February we're not dealing with the same things. I would rather go back to October and November and pull data from there to predict that. When you have that sort of seasonality where the nature of your work changes, you don't necessarily want to use more recent data. You would probably just want to go back and pick data that exhibits the same characteristic as you expect to come up.
Yeah, we again, we use this example all the time. In North America and Europe, for most teams, especially even if you're not dealing with taxes, for most teams, if you're trying to do planning for January in North America and Europe, it's generally speaking problematic to use December data to do January planning,
right,
because of all the holidays and everything. In the United States, so you might think, okay, we can't use December's data, so we'll go back to November. Well, in the US, that's problematic too, because you have the Thanksgiving holiday in there. So now we've got a decision to make. How far back do we go? Does October look like January? Do I have to go back to last year's January to look like January? That's really where this thing crosses over into being more art than science, which is honestly really how I want to wrap this up. But I don't know. Did you want to say anything more about the recent data before?
No, that's mostly it. It's if your data exhibits seasonality, you probably want to use the season that you're coming up towards with a similar season from before.
Right. So just to recap everything we've said so far, don't necessarily buy into the thing that more data is better than less data, because you generally speaking, you don't need as much data as you think that you do. Number two, more data doesn't buy you anything if you're going too far back in the past to get more data for the sake of getting more data, and or if, as Prateek said, your data exhibits seasonality. Even though you maybe want to skew yourself to having more recent data, if your data exhibits seasonality, now you got a problem. Which brings us to kind of the overarching kind of closing thing, which and this is maybe sad for most of our audience. It's certainly sad for us. Is that it really just comes down to common sense. I'm a big fan of Dr. Donald Wheeler, and he's got a great saying. I think he got it from Short, but I'm not sure. I'll have to go check that out. So please forgive me if I attribute this wrong. But Dr. Wheeler loves to say, data has no meaning apart from its context. Mm-hmm. And so that's when you're doing this analysis, when you're doing this forecasting, hopefully you understand the context under which the data was collected, so that you can have a meaningful conversation about, all right, what of this historical data really should we be using to do our forecasting?
I don't think there's much to add. I mean, if you quote yeah, I mean, like if you quote Dr. Wheeler after that, I don't know if I have much to add.
And so that's why, I mean, so, a bunch of experts might be out there telling you how much data you need and what data to use and things like that. At the end of the day, it really just comes down to common sense. Hopefully we've given you some tips and tricks of some things to think about, some things to watch out for, as you go through this, but it's really going to come down to you as the data analyst or the person doing the forecasting to use your own common sense to be able to do the relevant forecasting.
Yeah. And I mean, as we have said over and over again, you want to make as little investment as possible to get to as confident an answer as possible. So do not invest time and effort going into old systems and pulling data and trying to get 3 years of data to answer a question. You're probably better off getting the last 30 days of data and answering the question with that.
So that's it. We gave Prateek the last word. For Nisha there in the background, for Prateek Singh, my name is Andy Vacanti. Please join us next time for more of my number twos and hopefully more insights in forecasting and predictability and whiskey. So everybody have a great evening, and we will see you in the next video. Good night, everybody.